Now this illustration deals with location and type of protection in accordance with 240.100A. And here we're showing maybe where a relay system was used, circuit breakers were used, or fuses were used. But basically here we're in an industrial, supervised location where we would have qualified people and probably engineers available on site to make sure that equipment was properly protected, to make sure we, as maybe electricians, didn't overload the equipment, not realizing what we might be doing if we were electricians. If we were engineers, that's why sometimes engineers in a facility will not allow load added to any system without coming through them, because they have the charts, they have the diagrams, they have the one-liners, the schematics, they have a lot of this stuff on a computer sometimes, so they know what load could be added, if any at all. Now notice the top illustration. We have a circuit breaker feeding that transformer. Off of the secondary side of that transformer, we have fuses there that are protecting that transformer from overload. The left-hand side shows a circuit breaker, and it's protecting the transformer from overload, and also the overcurrent devices below it feed branch circuits and feeders or whatever it be the case. But now the equipment that you see in the center is a relaying type system. And I could actually design that as the installer to have a relay at the service equipment that communicates or compares, as we'll see later, with the downstream relay, and we either communicate with it. If it loses more current, then we're going to open it up. If a ground fault, short circuit, or say an overload occurs that we know would damage components, conductors, terminations, and so forth, then we could open it up. So you're placing the relay system in such a manner that the relay upstream is either comparing, usually, or communicating with that relay downstream to provide the protection scheme. So here we're either using circuit breakers, fuses, or relays, showing you all three in one drawing. So you would want to keep that in mind. Then again, only qualified people should be monitoring these systems to make sure that someone unqualified didn't do something that could create a tremendous hazardous situation. Now notice in the equipment to the left, the overcurrent protection circuit breaker is complying with 240.92C as in car 1 and C2 as in car. And notice the grounding of the transformer takes place to the structural building steel in accordance with 250.30. Now, the single overcurrent protection limits the load to the based upon the ampacity of the conductors and the output of the transformer in accordance with 240.92C2 item 1 and 240.100B. The fuses that you see to the right in the equipment is used for overload type protection and protection too from short circuits and ground faults in accordance with 240.100A2. And then the relay system that you see is installed in accordance with 240.92C as in car 2 item 3 in conjunction with 240.100A as in apple 1. Now, this really gets you started good. Again, I'll point out, just if you want to do this, but the Stallcup's electrical design book, and you look at chapter 10, I believe it is, high voltage, medium, and high is discussed there. And what you see here is explained in greater, more detailed information. So As you know, Volume 1 is more basic information on the code and how to design, install, maintain, and inspect. Volume 2 is more advanced. So we suggest go through Volume 1, look at the illustrations first, and then go through Volume 2 and look at it. Then you understand just exactly what's taken place in both volumes. But if you start one, say Volume 2, without looking at some of Volume 1, it's a little bit harder to understand. You have to have a little bit more knowledge on design, installation, inspecting, and maintaining, and so forth. So this figure 9-46C is illustrating the three methods of design using circuit breakers, fuses, or relays in accordance with 240.100 and 240.101.